Okay, so now we're on to question 8. We have got transformations coming up. There we go. So it says triangle A and triangle B are drawn on the coordinate grid. Part A, describe fully the single transformation that maps triangle A to triangle B. So I'm going to get this tracing paper and we'll sketch around triangle A. Now it can't be a translation because, it can't be a reflection because if we flip, that's not going to be the same, so it must be a rotation. And if we are very careful, it's going to be a rotation around that point just there. So that is for the 3 marks, rotation, 180 degrees, about the centre of rotation, -1, 0. Okay. So 3 things, the type of transformation, and because it's a rotation, the degree of turn and the centre of rotation. Then for part B, describe fully the single transformation that is equivalent to a reflection in the line x equals 3 followed by a translation 4, 0. So let's just mark on the line x equals 3, that's obviously a vertical line. And if we were to flip, then our shape will end up just here. Okay, draw that in. Then we are going to do a translation 4, 0, so that's horizontally 4, and that's going to be going this way. 1, 2, 3, 4. Let's draw that in. Now, we are working out how to get from shape A to this shape here. So, in a single transformation. So we can tell it's not going to be a single translation, it's not going to be a rotation, so it's going to have to be a reflection. Now the easiest way to find the mirror line for reflection is to draw the 2 shapes, get your tracing paper and fold over and crease it so that when they're exactly on top of each other, that crease is the mirror line. So if we put them back, that crease is along x equals 5. So the single transformation is going to be a reflection in x equals 5. Next up, we have got, the diagram shows triangle ABC. CD is parallel to AB. AC and AE lie on a straight line. And angles of size A, B and C degrees are shown. Okay. Now it says, insert A, B or C to make this statement true. Give a reason for your answer. Angle DCE, that angle there, equals, well, it's going to be A degrees. And the reason for that is, if we highlight the other A, we've made that F shape, so it's corresponding. Oh. Whoops, did my G too early there. Corresponding. Okay, use the diagram and answer to part A to show that the angles of a triangle add up to 180 degrees. Give reasons for each statement you make. Okay, well, we're going to need to work out what this angle here is. And if we highlight angle B, ta-da, it's B degrees. Okay, so BCD equals B degrees alternate. That's because it's a Z this time. Okay. And then we know that angle ACE equals 180 degrees. It's a straight line. Okay. And we know that ACB plus BCD plus DCE equals 180 degrees because they make the straight line. So that's A degrees plus B degrees plus C degrees. Oh, other way around, sorry. That's C degrees and that's A degrees equals 180 degrees. Angles on a straight line. So that's angles on a straight line. And then we know that triangle ABC is made with angles A, B and C, so must sum to 180 degrees. Something along those lines. Right, next up. Geordie invests £25,000 at a rate of 2% per year compound interest. Calculate the total amount of interest you will have earned after 5 years. I'm going to use decimal multipliers. So we've got our starting amount, 25,000. Because it's an increase of 2%, we're going to be multiplying it by 1.02. That would be 1 year. If we're going to do that for 5 years, we'd be multiplying by 1.025 times, so we can do that as 1.02 times, 25,000 times 1.02 times, to the power of 5. Okay, now, if we pop that into our calculator, we will get the answer, 27,602.02008. That is how much her account is now worth. We need to find out how much interest she will have earned. So not how much money she's got, how much interest she will have earned. So we're going to do 27,602.02008. Take away the starting amount of £25,000, which will give us the amount of interest that she's earned in that period of time, £2,602 and 02008. We need our answer correct to the nearest penny, so that's going to be 2 decimal places, 2,602.02. Final answer. Okay. The area of a rectangle is 56 meters squared, correct to the nearest meter squared. The length of a rectangle is 9.2 meters, correct to the nearest 0.1 meters. Calculate the smallest possible width of the rectangle. This is a bounds question, so we're going to find upper and lower bounds for our area. So if it's 56 meters squared to the nearest meter, it could have been rounded down to 55 or up to 57. So our midpoints are 55.5 and 56.5. So lower bound, upper bound. Then same again for our length. It's 9.2 meters to the nearest 0.1 of a meter, so it could have rounded down to 9.1 or up to 9.3. Midpoints 9.15 9.25. Lower bound, upper bound. Next, we are going to have to calculate the smallest possible width of the rectangle. Well, we've got a length and an area, and we want a width. So we're going to do area divided by length equals width. And we want the smallest possible. To get something small from a division, you want the smallest thing to be divided, so 55.5. And we want to divide that by the largest thing that we possibly can, 9.25. Which comes out at exactly 6. That is the shortest length of width. Next up, some sequences. This sequence is going up by 5 each time. Like the 5 times table, so that means it's going to be 5n. But the 5 times table does not go -1, 4, etc. So we have got to each time, subtract 6 from the 5 times table to get to our values. 5n minus 6. Okay. Now this is another sequence question, quite a tricky one, which is going to lead to some simultaneous equations. We are told the nth term of another sequence is given by an squared plus bn. The third term is 9 and the sixth term is 126. Find the values of a and b. So I'm going to create 2 equations, one to show the third term equaling 9 and the second to show the sixth term equaling 126. So to do this, if it's the third term, n is going to be 3. So my first thing is going to be a times 3 squared plus b times 3. And that's going to equal 9. And we can tidy that up to make 9a plus 3b equals 9. My second equation is n is going to be 6 because we've got a sixth term. So we're going to have a times 6 squared plus b times 6 equals 126. And we can tidy that to 36a plus 6b equals 126. So this is equation A, this is equation B. The first thing I'm going to do is I'm going to get the same number of b's in each of my equations. So I'm going to do a times 2 to get a new equation, C. That means 18a plus 6b equals 18. I'm then going to subtract c from b. So we're doing b minus c. Okay, and that means we will end up with 36a minus 18a. That's 18a. And 126 take away 18, that's 108. Then I'm going to find a by dividing through by 18, which means a equals 6. And double check all that in the calculator. I'm then going to substitute a into a. Give me a new equation, which means we've got 9 times 6 plus 3b equals 9. 9 times 6 is 54. That's, yes, it is, yeah. Plus 3b equals 9. I'm going to take 54 away, so we've got 3b. So 3b will equal minus 45. Therefore, b will equal minus 15. And then we just need to plot that on our answer line. A was 6 and b was minus 15. If we had time, we could take a and b that we've just worked out and substitute it into equation b, and it should work out to be 126.